Okay, so why BDNF? This is a question I haven't answered yet on this channel in terms of PTSD and your whole HPA axis being thrown off, dysregulated. Why worry about BDNF? Well, okay, if you haven't watched the video where my analogy is the Godfather and his family for understanding the whole HPA axis, watch that. That'll help explain some of the gaps here. But anyways, let me give you a physiological concept that you need to understand in order to take in why BDNF is so important. So, physiology concept number one. In the body, cell death and cell birth have to more or less be equal. Now, within range, close to one another. This is in every system of the body. Now, some people have this concept that cells are static, that you have cells and then whatever, that's life. And then once they die, they die. The truth of the matter is there's constant turnover of all your cells in your body to varying extents. Part of this has to do with the function of the system we're talking about. So let's pretend you're a stomach cell. If you're a stomach cell, you're cozying up next to the food, right? Sounds like a good situation. Oh yeah, be a stomach cell. But you're not long for this world. Your lifespan is not all that extensive because you have to withstand acid, typically in the neighborhood of 2. A pH of 2 is more or less what the stomach has to withstand. And so the cells there tend to turn over fairly quickly because acid can be fairly corrosive. And so eventually you take some damage to DNA, mutations, and you get taken out. Other cells in the body, the lifespan varies. Red blood cells, average lifespan between 90 to 120 days. Why would that be? Well, they have no nucleus. If you're a red blood cell, contrary to, the rest of the cells in the body always have a nucleus, command center of the cell, telling the cell what to do. Red blood cells eject their nucleus along with the mitochondria, so they have more space for carrying oxygen and carbon dioxide. Right? They're the taxi cabs of the whole system. So they take out the seats so they can hold more passengers in the back of the van. Lovely, huh? Now, if you're a cell of the nervous system, meaning you're a neuron, your lifespan is fairly long because, one, it takes you a long time to grow. And some of the largest cells in the body are in the nervous system. Let me give you an example. You have the cell body. Let's pretend it's a neuron and it's in the base of the spine. There's what's called an axon, which is this long finger-like projection where the electrical signal for the neuron fires. That has to go all the way to the receptor site, which could be in your big toe. So the size of the cell is the length of your leg, more or less. Now, might not sound like very much if you're someone who's vertically challenged like myself. But if you're Shaquille O'Neal, that's a long ways. So the growth of your neurons occurs over time, and as you grow and develop as, through adolescence and into even about your early 20s is when your nervous system finally finishes developing. Because just as your leg is growing, the neuron has to grow to accommodate that, along with this, what's called a myelin sheath. It's this insulin covering over the axon to keep the signal firing well. So that's part of the nervous system, and cell growth and cell birth is very slow. It's so slow that when I was in medical school, we were taught that nervous system cells do not regenerate. Once gone, they're gone. But that's not the case. We've figured out in the past maybe 15 years, maybe it's been longer, that this brain-derived neurotrophic factor actually is part of what tells neurons to to grow. It also tells parts of the cell to repair itself, to basically cellular genesis, and also long-term potentiation, which is this process of converting really short-term memory to long-term memory. And what you do is you play back some of the, as far as we think we understand, you play back memories while you're sleeping to convert them into long-term memories. And it's called long-term potentiation, and it's tied into neuroplasticity and cell growth. And you have to have new places to lay down these memories, and thus you need more space, more neurons, more nervous tissue. So it makes sense that our brains actually are fairly, they're living tissue. But, as was mentioned earlier, the part of the brain that takes a hit has to do with cognition and memories, and also stability of moods, and therefore we want to target turning BDNF on in those areas, because what happens in, as I mentioned earlier, in PTSD and in HPA axis dysregulation and in mood disorders, you have this net loss of the cells. The cell growth, the cell repair does not keep track with cell death. So you have to target things to try to influence factors that are going to turn on cell growth, cell repair, and this neuroplasticity. So that's one piece. But again, is it possible to turn on BDNF too much? I think so, yes, because cell growth and cell birth and cell death have to keep pace with one another. If you have net cell growth, cell repair, and you're not in a state where you would need such a thing happening, such as, pregnancy, obviously, you're growing a new life, you're growing a disposable organ in the form of the placenta. So, of course, cell birth and cell growth has to get ahead of, there's to be a net gain. That makes sense. But if it's not such a scenario, if you're not a child who's growing in stature and in other ways, then you don't want to be in a state of too much growth, because that's what we see with cancer. Right? You have this uncontrolled cell growth and these rogue cells that are no longer listening to signaling from the rest of the body that says, wait a minute, okay, we got enough of those stomach cells replaced. We don't need 50 million. You may think you do because you're a stomach cell, but you don't. And that's what happens with cancers. You usually have 2 genetic mutations that have to occur, but the growth gets uncontrolled, and so potentially something like BDNF, if it were turned on too extensively, that could be a problem. I'm guessing. We don't know this for sure, but maybe in that scenario, it could be connected to cancer, which is why a conservative approach in my mind is best. You do natural things. You aim to influence BDNF rather than specifically injecting, a drug that causes BDNF or acts on the receptor somehow. You're kind of like playing God. And it's probably a better approach to do things such that we know are already good for us, like exercise, to influence and turn on BDNF in this way, because it's sort of, the two-step approach, because it's likely that the body has mechanisms in place to adapt to if there's too much BDNF. But again, getting back to the scenario of PTSD or HPA axis dysregulation, you're trying to catch up. So my thought is turning on BDNF, increasing BDNF levels in this kind of scenario is one way to target and strategize restabilizing the HPA axis, and also to repair the regions of the brain that most need nurturing and repairing from a physiological standpoint. So this is one way to do it, is my guess. We're going to get into this more on this channel, so if you haven't already, go ahead and subscribe. Trust me, it's not a self-destruct button. And I'm gonna cover more along the lines of specific things we can do nutritionally to influence stabilizing the HPA axis and BDNF. So there you have it. Thanks for tuning in, and adios. Oh, I always love thumbs up and all those other YouTube things, so don't forget to do them.